Good morning, everyone, and thank you for joining today's webinar, Modernizing Application Deployments with HashiCorp Consul on Microsoft Azure. Our speakers today are going to be Nick Jackson, Developer Advocate at HashiCorp, and Eugene Churyov, Senior Cloud Architect at Microsoft. Throughout the webinar, please feel free to answer your questions into the chat box. And as a reminder, this session is being recorded, and we'll make the recording available after post-processing, typically in 1 to 2 days. And with that, I'm going to turn it over to Nick Jackson to get us started. All right, Nick.
Hey, how's everybody doing? Well, I hope. So it's going to be fun today. I'm really looking forward to this because there's nothing I love talking more about than console and service mesh. And I'm joined with Eugene, who's going to be talking about AKS and some of the things that we're doing together. But let's kind of begin and let's kind of kick things off. So what I kind of want to open up with is something that we've been floating around called the cloud operating model. And there's a white paper which you can read on the HashiCorp website about this. But the concept is this. It's that you kind of end up with this stack. You have a requirement for development and networking and security and operations. And kind of getting this stack right is the key thing to being able to kind of accelerate your application delivery and not having all of this sort of modern stack as a kind of a hindrance to it. And I suppose one of the key things for larger organizations is that when you're thinking about this stack and you're thinking about this cloud operating model, you've also got to be thinking about policy and you've got to be thinking about governance. So HashiCorp built a suite of products which tie into this kind of concept. And we've got Nomad, which is a scheduler, and it's kind of your deployment layer. So you can do things like run your Docker containers, you can run Java applications, raw binaries. Similar in some concepts to Kubernetes, as they're both schedulers, but very different in others. And then there's Consul, which is the networking layer. And the networking layer kind of spans right the way through the stack. And that's what we're going to be talking about today. And how we've sort of updated Consul and brought it from just a tool which was purely used for building modern environments to building really modern environments when we're dealing with schedulers and being able to manage network security and network locations and network load balancing and all sorts of everything networking. And Vault. And Vault's a tool which is designed for managing secrets, for managing static and dynamic secrets, for managing the ability to offload encryption, to run encryption as a service. So any of your cryptographic needs from securing your data, but also being able to kind of weave, as I said, cryptography as a service, offload that so you don't have to deal with it as a developer. And one of kind of the most popular tools is Terraform. And being able to manage your infrastructure declaratively, being able to manage infrastructure as code to make it repeatable and consistent, all of those tools there tie into, as I say, this operating model, really, really useful way of developing modern applications. So Consul. So why are we here? Why are we kind of talking about Consul? Why was Consul originally kind of developed? Well, the concept around it was that you're dealing with modern applications. They're highly distributed. And you've got to be thinking about that shift from static location-based networking, fixed point IP addresses on bare metal machines, to more dynamic networking. So how did that move? Well, as a market, we've moved from the monolith to the microservice. We started off with a single physical server, and certainly the first web application I built in, I think, 1999 was running on 2 application servers. There was a web front end, PHP, and there was an Oracle database running on 2 Sun Solaris boxes. That was great back in 1999, but we've got greater demands on our systems, and that forces us to kind of shift the way we build things. So we started to break things down and to virtual machines, and that gave us a great capability around deploying things. It was so much easier to kind of spin things up than having to provision bare metal. With the cloud, that went one step further, and we started to get infrastructure as a service. So we didn't even need to own the physical machines anymore. We didn't need to wait for 3 months around procurement and racking of those machines. We can just spin them up as and when we want using sort of cloud resources. And that worked for a while. But more recently, over, I would say, the last sort of 4 years, there's been a shift to smaller applications. So we started to use containerized applications, microservices. And kind of why we're there is that the applications are becoming more complicated. So the applications are bigger, they're more complex. We need a way to break them down in order to be able to effectively develop them, but also for the teams to be able to understand the particular domain around a system. Where that's left us is that we have a very sort of different situation in terms of networking. It's not a bunch of machines which are connected, physical routers racked in a data center anymore. We are not even using single data centers. We're spanning across multiple data centers and potentially multiple clouds. And what we need to do is we need all of those application instances, of which there are many, because we're dealing with microservices, and we need to be able to get them to communicate. So anybody who's ever tried to do this and tried to kind of manage static IPs or use a sort of a combination of maybe DNS and things like that knows that it's really, really difficult. And Consul was introduced about 4.5 years ago to start to solve that problem with virtual machines and with microservices as we started to emerge and move into this kind of containerized workload. So with Consul, what we have is a different approach. So we're going to use a centralized registry to locate any service. We're using kind of a service catalog, so we don't need to directly understand the IP address. Of course, we can't sort of maintain an IP address in our local application because applications are changing. They're getting rescheduled all of the time. So that catalog needs to be up to date. It needs to be highly dynamic. And we want to kind of be able to enforce zero trust, because one of the problems when we're moving to a dynamic infrastructure is how do we configure things like network and service level segmentation when we don't know the location of either party which needs to connect? So this led us to kind of build on those core features of Consul and introduce Consul as a service mesh, bringing it kind of the requirements that we were asked for by our practitioners. There's kind of 3 components in a service mesh, and they are networking, which we're going to be talking about today, observability, and reliability, kind of the 3 pillars of service mesh, I like to think of them. So with networking, it's all about dynamically locating application instances, being able to dynamically route traffic in a smart way, including being able to do things like canary deploys or dark deploys, but also being able to simplify network security, being able to kind of think about a service as a service identity as opposed to service location. And there's observability, because when we're running in a sort of modern environments, we're running in the cloud, networks can be a little bit fragile. You're moving your communication in terms of the function calls which were in process to something which is happening over the network. And we need all of that information. We need to understand how that's behaving. Are system calls failing between services? Are there error messages? And being able to kind of do that without having to add a huge amount of metric augmentation to our code is one of the great features of the service mesh. And again, that observability is kind of linked around that sort of network request information, layer 7 as well as layer 4. And because we've kind of got those slightly fragile networks, and not all of the time, it's all transient failure, we need to be thinking about reliability patterns. So how do we build redundancy and failover? How do we manage things like timeouts, retries, circuit breaking, the kind of the core patterns around microservice reliability? Again, the service mesh can take that weight away from our development code. We don't have to follow the pattern of the kind of the Hystrix pattern of the fat client where we're baking all of this into our code. We're sidecarring it, we're offloading it, and we're leaving it to the responsibility of that dedicated network layer as the service mesh. So how difficult is it to create a service mesh? How difficult is it to run Console Connect? Well, let's see. So Eugene is going to spin up an AKS cluster, again, using Terraform. So we're right into that cloud operating model. And then we're going to look at how we can deploy Console onto it using Helm. And we're going to then deploy an application to the cluster, and we're going to use SMI to manage those intentions. So first things first, Eugene, over to you. Can you Terraform me a cluster, please?
Well, hey, Nick. Hello, everybody. So my name is Eugene Shuvarov. I work for Microsoft, and I've been working with HashiCorp for about 3 years now. And let me go ahead and jump right into code and actually show you guys a couple of things that we've been working together. So as Nick mentioned, the first step is this multi-step demo is to provision an Kubernetes cluster. And to do this, I'm going to leverage a module from Terraform Registry. Most of you probably have heard about Terraform Registry, registry.terraform.io. And so the module that I'm going to use is the Azure Kubernetes module, very intuitively, or AKS. As you can see, we just published this recently. So very straightforward and simple to use. I'm just going to peek in my simple config file. You can see the module code here. The source is Terraform Registry. I pass in just a handful of variables to stand up this cluster. So I'm just going to go ahead and start doing this. And the very first thing to do is just say Terraform init, certainly. Then we're going to plan and just try to plan out into the aks.out file. So it should say we're about to provision 6 resources. Very good, that's expected. And the final thing I'm going to do is Terraform apply, aks.out. So take that plan file that we wrote and just go ahead and execute that. And so while this thing provisions, let me just, Nick, let's go back and switch to the slides and let's talk about the Azure Kubernetes service in general. So let's go ahead and switch. So what is Azure Kubernetes service, right? So the Azure Kubernetes service is our managed Kubernetes offering. And if you can focus kind of on the bottom portion of the slides, what we provide, what we Microsoft provide for you with this managed offering is obviously cluster hosting, but also the upgrades and the patching and scaling and monitoring and logging. All of those things are managed by us. So contrast this with the column that basically is in the middle, which is what you would have to do if you were to kind of roll your own Kubernetes clusters and you had to manage them yourself. I mean, all of those functions would have to be performed by somebody in your organization. In addition to obviously hosting, upgrading, and patching, we partially automate containerization, and we enable and give you tooling to actually configure the CI/CD pipelines, to provide this inner loop of application development that I'm just going to cover shortly on. But basically, in a nutshell, really we kind of take a lot of the heavy load of managing Kubernetes away from you with the Azure Kubernetes service. Next slide, please. And so one data point that is fascinating to me, because I remember actually talking about Azure Kubernetes service just a year ago. So it was first made generally available in June 2018, just 1 year ago. And since then, we've seen it grow 30 times. And so you can see some of the companies using AKS. My team, my extended team, actually works with a lot of customers. And I can certainly say that the momentum that Azure Kubernetes service is seeing is almost unprecedented, so to speak. So next slide, please. And to kind of look back to why customers are choosing to go with Azure Kubernetes service, is because of the things we already talked about, such as reliability, management, the fact that we provide server monitoring, self-healing, all of those things kind of basically all of those management things are provided to you at no charge. And actually, Nick, I think if you click, it will animate the rest of the slide as well. So so all of those things, reliability, easy secure scaling, self-healing, also referred to as managed control plane. Again, just are provided to you at no charge by us. So in addition to managing and providing certain things at no cost, we have this feature called Virtual Node that allows you to scale instantly, or almost instantly, I should say, into something that's known Azure Container Instances on our platform. And the benefit of Azure Container Instances is the fact that you can spin them up really quickly. You get billed by the second. So if you need this instant bursting capability without potentially the overhead of Kubernetes scheduler provisioning things, Virtual Node is one feature to look at. So we are continuing to innovate in Kubernetes space. If you can go to the next slide, please. I think we just announced that we are supporting Azure Kubernetes Service in 27 regions, in 27 Azure regions around the world. That's more than any other public cloud provider out there. And the innovation in that space inside our company continues just in a very accelerated rate. To kind of summarize the AKS on a single slide, here's just, you can basically think about three pillars that we are innovating in that space in. So first is the inner loop and the focus on developers, right? And there we have this concept called Azure Dev Spaces, which allows you to really debug your Kubernetes applications with ease. So using Visual Studio Code and a couple of other features that we have. So definitely Azure Dev Spaces, if you're developing with Kubernetes, if you're an application programmer, that's something to look and investigate. And on the delivery side, you can certainly see the Terraform, basically the Terraform icon there. We certainly utilize Terraform heavily. We've seen that adoption grow exponentially over the last 3 years. And it also factors into the AKS provisioning, which is kind of what we're showing now. And while I'm talking about AKS, hopefully the cluster has stood up and is ready for us to use. But also, not just in development and not just in delivery, but also operations. So once you provision AKS cluster, we provide you the tools to monitor, we provide you the tools to scale, and just really work with your Kubernetes cluster as you would kind of expect things to work. So I think that's all I wanted to cover on the slides. If we can go back to the demo, let me minimize the screen. Okay, I think we're almost done provisioning. But basically, I guess maybe we just, we're almost done. It was 5 minutes during the practice runs. But once we're done with this piece of infrastructure, then we'll go back to the next step in the demo, which is actually deploying Consul on top of the Azure Kubernetes cluster that we have set up. And to do this, I'm just going to pull up my notes really quick. And I'm going to copy this into clipboard. Okay. All right. Come on.
Hey, Eugene.
Yep.
Now, nobody's saying that webinars might be a little bit of smoke and mirrors, but if anybody's a fan of cooking shows, you will know that the key success to a cooking show is not waiting for the cake to bake, but it's having a cake which is ready in the oven already. Shall I bring out the cake that's ready in the oven already?
Certainly. Why don't we just go ahead and switch to the Consul cluster we're already provisioned?
Cool. And we can always come back to this.
Absolutely.
So one of the things that that we were going to kind of show you, and we'll show you that when it comes up, but installing Consul on Kubernetes is really straightforward. So we have a Helm chart, and configuration of the Helm chart is pretty minimal. So all I need to do to kind of set up Consul Connect and to be able to run service mesh in Kubernetes is to set a few of these options. So bootstrapping ACLs, and we'll talk about this in a little while, but this is the internal security mechanism for Consul, because you don't want anybody being able to do anything on your Consul server. And we can set the number of replicas. So ideally, we want a quorum to have high tolerance, so 3, 5, or 7. And bootstrap expect is the number of replicas before we acknowledge that the cluster is ready. And of course, we want to enable Consul Connect. And to accompany Consul Connect, we're going to be using the new gRPC interface, which the data plane Envoy is going to use to configure itself. I'm going to use this great feature of Consul, which is Consul Inject, and that's going to allow me to just add data planes and configure up my pods just using simple annotations. And optionally, you know, the UI is really useful. I kind of believe that UIs are kind of a read-only view, but they do give you a really rich overview rather than just having to dig through the CLI. Central configuration, again, a new feature, and that's going to allow us to configure all of our data planes which come up with a set standard. So for here, I'm just going to be configuring an observability feature, which is just setting my dog_stats_d location to be able to get the metrics out. And I'm going to set that for every one of those pods that I'm going to spin. So we got the cluster up and running, and you can see we're just running a single node server because it's only a little cluster I'm running here. But the Consul Connect injector webhook deployment, that's going to take part. It's the custom CRD, which is going to be able to allow us to do that injection. And we've got the Consul server, and then we're going to run a Consul agent on every node, because you don't interact direct with the Consul server, you interact through the agent. So here we go. So here's a Consul cluster. We've got our nodes. We can see the key value, the access control. I'm not logged in with an access token, so we're not seeing anything in there. And we've got these intentions, which is our security policy. So let's have a look. So, well, I suppose what we should do is have a look at deploying an application to the cluster. So let's go ahead and do that. So I've got a very simple application. It's only 2-tier. So I've got an API, and the API is just going to constantly increase a count, and I've got a dashboard. So the dashboard is my graphical UI, which is going to show the data from the dashboard. So what have we got here? So we've got a service account, and this is going to be important. So do you remember I said to you I was enabling the access control list? So what we want to be able to do is we want to ensure that a service can only obtain an identity by which it's entitled to do. So think about it, if somebody breaks into one of your services, front-end code exploitation, if they can reconfigure that service to masquerade as any other service in the service mesh, then you've just broken down all of the network security that you've spent all that time implementing. So by using the access control lists and by configuring a service account, what Consul is going to do is it's only going to allow a service to assume the identity of dashboard. So standard deployment, nothing sort of unusual there, but then we get to the annotations, right? So an annotation, Consul HashiCorp Consul Inject true. What does that mean? Well, what that means is that you can see here I've just got a single container in my deployment, but by adding this annotation, what's going to happen is Consul's going to automatically add the Envoy data plane. It's automatically going to bootstrap my access controls based on the service account, and it's going to set everything up for me. I don't have to manually configure anything like that. I do it with a single line. I'm providing an optional parameter here, which is console.hashicorp.com connect service, and I'm giving it the name dashboard. If I didn't actually specify this, then the connect injection capability is going to pick up the name of the first container, but I like explicit, so I'm explicitly. And then here I'm specifying console.hashicorp.com connect service upstream. So what's an upstream? Well, an upstream is a reference to another service. So in this instance, to my API service. Now, when I'm using the service mesh, what I'm actually doing is I'm telling Console to expose the API service on localhost at port 9001. So I don't need to have my application doesn't need to have any knowledge of load balancing or service location or anything like that. All it's doing is talking localhost. And because I've got that configuration there of my service upstream, any request that I send to localhost 9001 will automatically be sent to an API instance, and it'll automatically be load balanced for me through the data plane. So let's get those services up and running. So again, nothing fancy going on here. I'm just going to kube control apply my API. You can see there are 3 API pod instances coming up there. And I'm going to apply my dashboard. And again, we're going to see 3 dashboard instances coming up there. So my API is up and running. Just going to wait for Kubernetes to create me my dashboards. And we've got that. So what we've got is a load balancer. And I've got my counting dashboard, which is running on this IP address. And that's public. So if anybody wants to play, you can feel free. So if I go over to my browser and I refresh my browser, then you can see that I've got my dashboard there, right? Now, look in the right-hand corner. What you're seeing is counting service is unreachable. So I've specified that intention, that upstream, right? But the service mesh is only going to allow traffic which is explicitly declared through these intentions, and I have none. Because I'm using the access control system, by default, every traffic is denied by default. So I can see my services again in the UI, I can see my dashboard, I can see the different deployments, and I can see I've got my sidecar proxy, my data plane. And I can see that I've got all my health checks, my node checks, and I can see that I've defined this upstream. But it's not running yet. And that's because I haven't configured those intentions. So how do I do that? Well, I could manually do it through the UI. I could use infrastructure as code, or I could use the service mesh interface, which is a new innovation sort of pioneered by Microsoft, but it's a community initiative and it's backed with a number of different folk, including HashiCorp. So Eugene, do you want to give us a little tour about the service mesh interface and what that's all about, please?
Absolutely. So service mesh interface is something we just announced just a couple of weeks ago, literally. KubeCon Europe, that's where the announcement was made. But basically, just kind of let's take a step back and just see kind of just think about the things that we're covering today, right? There's Kubernetes, the basically service, there's service mesh, there's service mesh interface. So those are not easy concepts by any means, right? Just to understand Kubernetes probably takes, at least in the experience working with customers, it takes a while for people to just get wrap their brains around that. So just sort of like created this diagram of perhaps, there's a good set of people who understand Kubernetes today, And the subset of people, those people, probably not a very large subset, understands service mesh. And then just sort of like for a quick reference, there is this orange dot that says technologists who understand or service mesh interface. That certainly is very limited audience, limited to just the attendees of KubeCon and just what we're going to be covering today. So sort of like as we increase exponentially, almost, it seems like the complexity of this stack, you just kind of pause and think, well, should it really be this way, right? Next slide, please. And so in our opinion, it really shouldn't be this way. I mean, it really should, the way it should be is that people who understand Kubernetes, they expect a set of network functionality available to them. And this network functionality, at least initially, we think falls into these three buckets. So the first one is the services should have an identity and they should be able to communicate securely. The second one is communication between services should be logged and monitored. And the third one is the traffic patterns between services should be configurable. So perhaps to allow for A/B testing or newer service version deployments, etc. So along those three buckets, this is where the concept of service mesh interface emerges. So what if we define a specification that kind of allowed people or basically vendors to plug into and make this functionality available to Kubernetes users or programmers or technologies. So, and then kind of this functionality historically was achieved by smart endpoints. Smart endpoints, dump pipes. This slide is animated actually, Nick, so if you click again, the dump pipes worked for 25 plus years. But today, I mean, with, as we already mentioned at the beginning of this webinar, with so many microservices and just so many different pieces moving, especially in the cloud, especially in the public cloud, I mean, this the dump pipes technologies just are no longer viable. And this is where basically smarter pipes with service mesh come in. So next slide, please. And certainly there are great products out there. And this slide actually is also animated. So service mesh technology is really all about smarter pipes, right? We take this functionality that was previously bundled into the endpoints and we make it available via the pipes. So next slide. And there's certainly great product offerings, great service mesh offerings out there already. There's Istio, which is very comprehensive with lots of features. There's certainly HashiCorp Consul, which is the subject of our webinar today. And really, one of the key features that stands out is the communication between services within the Kubernetes clusters and the services outside of it, such as services living on the virtual machines. And then there's Linkerd, which is very lightweight, and certainly many more products to come. Next slide, please. So, but if you were to develop against those products today, each one of them has a very specific interface that once you kind of program against, it is not easily swappable. It is just, you're just really very, very tightly coupled to that specific implementation. This is where service mesh interface concepts emerges. So in partnership with HashiCorp and several or many other companies, we have developed a specification that allows for the things that we deem essential for Kubernetes services to implement and to actually make available to people using Kubernetes. Next slide, please. So what are those things, right? Again, basically today, the applications and tooling and the ecosystem, if they wanted to talk directly to service mesh implementations, this is what kind of things would look like. Where service mesh actually kind of stands, is a layer in between the applications and the tooling that kind of provides a standard interface for consumers of those services to talk to. So if you click again, we'll actually see basically what service mesh concepts are in general. So it's a standard interface for service mesh on Kubernetes. So it's simple. Right now, we're just we're evolving it among three main pillars, which is basically policy, observability, and traffic management that we deem essential for our services in Kubernetes to support and implement. But it's also extensible. So while those 3 features may be our initial set that we're talking about, certainly newer features will become available and will get plugged in into service mesh interface. And so just to recap, in a sense, with service mesh interface, what really should happen is that basically the technologists who understand and work with Kubernetes and expect a set of networking functionality available to them, they should be able to get it with service mesh interface. And again, just as a recap, the services should have an identity and be able to communicate securely. Communication should be monitored and logged, and traffic patterns should be manageable. Next slide, please. And so certainly this is not a new concept. There's a concept of ingress, but also concept of standard networking interfaces, standard storage interfaces within Kubernetes are all kind of, I mean, the service mesh is really basically kind of falls along the same lines. It's an interface that allows people to get the functionality they want in a standard manner. And so the next slide, please. And to recap, why are we doing this? Why have we defined a service mesh interface is to allow people to get started quickly with basically certain services provided by service meshers. Start simple, allow people to just take advantage of those 3 key pillars initially and then expand as needed. And the final click, and it's certainly ecosystem friendly. So we will grow this over time. We welcome contributions, and certainly we view it as a very extendable thing to take into the future. And now over to you, Nick, to actually demonstrate how you implement service mesh interface inside Console Connect.
Awesome. So the last bit of the puzzle. Whoa, gosh, I'm going crazy. Too fast slides. All right. How do we use SMI to manage our integrations? So the thing we need to do first is we need to deploy the service mesh controller. And in order to use the controller, I need to provide it with an ACL token because, again, I'm securing everything in Console. I don't want any process to have unauthorized access to any of my service catalog or to obtain service registry. So the first thing that I'm going to do is I'm going to generate a Console ACL token. And I'm just going to give that a simple sort of policy. And of course, I lost my connection to my Console server. So let's just wait for kubeproxy to come back up. Thank you very much, kubeproxy. Right, let's run that. Okay, so I've got my secret ID. And I'm going to use this ACL token here. And I'm just going to put this into a Kubernetes secret. And let me just paste that in there, create that. So now I've got the ACL token in a secret. My deployment for my CRD is going to use that token. So let's deploy the SMI application, the controller. So kubectl apply console controller. All right, so that's going to load the custom resources into Kubernetes, the part of the SMI, and it's going to create that controller. So that controller is now up and running. So that's sitting there in the background waiting for requests. So what requests? Well, I need to configure those intentions because remember, Console's counting service is unreachable, and that's because I don't have that intention. So I can use an SMI to do that. And the SMI interface I'm going to use is I'm just setting up a simple TCP route, and I'm going to set up the traffic target. And the traffic target is the thing which allows me to explicitly allow traffic to a destination. So my destination is my API service, and the source is going to be my dashboard service. Now, if I was using a more advanced layer 7, I could have actually specified TCP routes, which would allow or deny traffic based on a path, not just simple connection, but we're keeping it simple here. So let's apply that. Total Kubernetes-centric workflow, kubectl, apply, -f, SMI, and that's going to run. Okay, so those have been created. Get, and then I can look for traffic targets. So I can see there, I've got my service counting target. If I go over to console and I refresh my window, you can see that based on that SMI declaration, I've created the intention from the dashboard service to be able to allow to be talking to the API service. If I go to my counter, you can see it's now working. It's connected because I've explicitly allowed the traffic to be able to flow from the dashboard to the API backend. And you know, I'm going to leave that running there. So this is not smoke and mirrors. This is legit. All right, nice and easy. So where do we go next? Well, we go next by looking at some of the other features. We've kind of just covered network security and network service discovery, but you know, the service mesh offers a whole bunch of other stuff. We've got layer 7 observability. You've got the ability to determine what's going on in your network. You can see the requests. You can see whether a request has failed with a 500, a 501, whether you're getting 404s. You can see the latency and histograms around the latency between those services. You can see tracing, so you can see the integrate relationships between different services, and all of that's available through layer 7 observability features. And that was introduced in console, I think 1.5. Some examples of tracing there, and we've just got an output from Jaeger, but you know, you can use any sort of compatible tracing, Honeycomb IO, anything like that to get this information. Gives you a really, really rich information about what's going on inside your service-to-service communication. Some charts. Of course, being able to have these metrics is absolutely essential. You can't have reliability if you don't have observability. And by using the service mesh, you get both the observability around your network and the reliability patterns without having to touch a line of code. So at the moment, we're only kind of dealing with a layer 4 proxy built into Console Connect, but we are introducing layer 7 routing, and that's going to be coming in, I think, the 1.6 release, which will be in this summer. It's going to give you the capability to be able to do routing and policy based on things like HTTP headers and paths. You're going to be able to do things like canary testing, gradual rollouts of your applications. So if you want to be able to kind of launch a new version of the service, you don't need to send 100% of your traffic to it. Send a fraction of the traffic to it. Use the observability, monitor it, make sure it's functioning, and then gradually increase that. Mesh gateways is going to be a big feature, which we're really excited about. And this is going to allow you to have a simple way to send traffic and communicate between clusters, between Kubernetes clusters and virtual machines, between private data centers and virtual machines, and private data centers and Kubernetes clusters. And you're going to be able to do this without having to worry about creating flat networks. It's going to be done securely because traffic that's communicated across cluster will be transparent point-to-point MTLS. We're not decoding the traffic at any of the gateways. It's just going to be nice and easy. And I'm going to be really excited to be talking to you about this very, very soon, I hope. Network gateways are really going to solve that problem. You know, it's great having a Kubernetes cluster, but it's also generally a gradual approach. We need to be able to thinking about our virtual machines. We need to be able to do the migration. And gateways are going to do that for you. Combined with the layer 7 routing, you're going to even potentially be able to do things like sending a fraction of your traffic to a completely different cluster so you can test your cluster configuration and not just different rollouts of versions. I want to thank you so much for listening to us today. I want to kind of sort of make a shout out and say that if there are any questions, please don't hesitate to ask them. And also, you can contact us at the address is there with any further questions. And I'm also available on Twitter as Sheriff Jackson. Love to hear your feedback. Love to hear some of the things that you're working on. And of course, there's the community portal, discuss.hashicorp.com. So any questions, please feel free to answer them there. And I guess we're back over to you, Peter, buddy.
Thanks, Nick. So we're going to go ahead and open it up for questions. We've had a couple come through on here. Nick, one of the ones that came up was asking about the differences between like Istio and Consul in regards to like a Kubernetes perspective. Could you maybe give a little bit of insight as far as how the two are differentiated because they're both considered service meshes?
Yeah, I mean, ultimately they perform a very similar function. So Istio is a Kubernetes first service mesh. It's designed specifically for the Kubernetes ecosystem. We took a different approach, and the reason we did that is because our customers and clients were asking us to be able to consider a service mesh which encompasses not just Kubernetes, but also virtual machines, and they need to be able to be linked together into one big mesh. One of the other considerations was that performance and scale. So Consul Connect is built on Consul, so you've got the ability to do the scale of 20,000 nodes if you want to do. People are using that in production right now for Consul, and the Connect capabilities scale as well. Feature-wise, we're going to hit sort of parity at a certain point. I personally believe, and I'm obviously going to say that based on the logo of my t-shirt, but Consul Connect is pretty easy to operate. It's also highly performant. And it also doesn't hit your Kubernetes API server at all because we're running independent servers. So, check them out, check out the benefits and the pros and cons between them both. And if I can help you at all, check them out. Hit me with any questions, but if you're just running a Kubernetes workload, maybe Istio's the right direction for you to take, but do your due diligence, check both products out. I think you'll like Connect.
Thanks, Nick. Eugene, we actually had a question come in for you regarding Terraform and the Azure RM provider. Could you maybe give us a little bit of insight about how you're working with HashiCorp to update some of the modules to make sure that they're working with like 0.12 and beyond?
Yeah, certainly. And I don't need to get on camera, I guess, on the webcam. Two of you guys is enough. Yeah, I see actually the question. So the concern is that obviously some of the modules perhaps may not be working with 0.12. It's actually a very good question because even in the documentation that we published, it's probably two or so years old, that somebody submitted a PR for where that you kind of failed the 0.12 check. And the error was really super simple. I mean, in a sense, obviously 0.12 is enforcing certain checks and balances that weren't there before. And really, from our standpoint, everything should be working. All the Azure provider, basically all the resources with the Azure provider should be working as of version of Terraform provider 1.27. So if you see inconsistencies, I'd love to hear about it. But also just a minor adjustment in syntax would potentially resolve those issues. And I have actually spot checked, probably excess of maybe 10 or 20% of all the examples we have on GitHub. So inside the Terraform for Azure provider repo, there's a lot of examples that the team has been putting there. So if you take a look at those examples, they all should be working with 0.12. So perhaps the answers to kind of actually why things are not working as expected are in there as well. And sometimes it can be just as simple as kind of a missing an equal sign and is now kind of strictly enforced via checks. But really, all of the resources should be compatible with the new version of Terraform Core as of 1.27. If they're not, I'd love to hear about it personally. I'm sure you will make our email addresses available after this webinar. But also, I would definitely encourage you to look at the examples in the GitHub repo and spot check the syntax there.
Thanks, Eugene. Nick, this was a question for you. So for Consul to work with an AKS cluster, does it have to be installed inside the cluster, or can it be installed on a VM outside of the cluster?
Yeah, it doesn't need to be an AKS at all, or any Kubernetes cluster. Consul can work inside of AKS, and you can have your workloads which are not running in AKS, like virtual machines, leverage Consul, or you can do things the other way around. You can have Consul running in virtual machines, and AKS can leverage its capabilities. You always have a Consul agent per node, and that's just this kind of the standard way the Consul architecture works. But the Consul server can run anywhere, absolutely anywhere. You could have it on bare metal if you wanted to. And that gives you the great flexibility of running those multi-mode workloads. Oh, and if you've already got a Consul cluster, as long as you're running a version, which I think 1.3 plus, which is when we first introduced Consul Connect, you just need to switch it on. So you can turn on Consul Connect in the configuration settings, and you can start leveraging it. One thing I will mention, which I've just thought about around AKS, is if you're not running Consul as a server using the Helm chart, then you will need to deploy the Consul injector in order to take advantage of those annotations. But that's a simple standalone pod. You don't need the full server running in there to take all advantage of the great features.
Thanks, Nick. So we had a question come up about the Helm charts, because you used Helm to install the application into Kubernetes. Could you go into a little bit more detail about how you used Helm chart, and also just kind of what role it played in our deployment today?
Yeah, so we were waiting on the cluster coming up, but what we have is a Helm chart. So the Consul Helm chart is available in GitHub, and to kind of install that, all I'm really going to have to do is I'm just going to do Helm install. I'm going to give it a name. I'm going to call it Consul, and then I'm going to specify the values. So the values are these files here. So these are custom overrides of the Helm defaults. If you look inside the Helm chart itself, you'll see all of the default values. So what I want to do is I want to override just a few of those, which I'm doing with this value file. So it's standard Helm stuff. And then I'm just going to specify the Consul Helm chart. Consul Helm is 081 currently, but I'm currently using master because it's got a couple of fixes for the latest version of Helm, which works great. And then literally all I have to do is hit install on that, and I've already got that running, so I can't show you, but it's as literally as simple as that. Just Helm install. The Helm chart itself, what it's going to do is it's going to configure the number of Consul servers that you want. It's going to install a Consul agent on every machine using a daemon set. It's going to install the Consul inject controller, and it's going to do some various different configurations, such as I'm going to set up the UI as a service. I'm going to initially bootstrap my ACL system, so that's going to create the initial ACL token. It's going to distribute an access control token to each of the clients so that everything's nicely secured. And some of the things that we've got in the pipeline for this, that we're going to do auto encryption. So you're going to be able to, through the Helm chart, automatically encrypt your gossip traffic, and you're also going to be able to automatically encrypt your encryption in transit between the various different Consul nodes by using TLS, and all of that will just be a configurable option inside the chart here. So it's really easy to use. It's pleasantly so. Consul's not a difficult tool to install and operate, but this really makes it a breeze. And we'll put the source code of all of the values that I was using today That will be in GitHub. I'm just going to clean up that repo and we'll send out the link. But you can also find the console Helm chart in github.com/HashiCorp/console, Helm. Oh, there we go. And that's there. We're going to put that into a formal Helm chart. And as I mentioned earlier, if you have any questions or any comments about any of the things that we've talked about today, then please take advantage of discuss.hashicorp.com and post up something there. The nice thing about asking you questions through Discuss is that it leaves them there for others to read. So it's kind of our own little personal Stack Overflow.
Awesome. Thank you so much, Nick. So we did have one more question just come through. So what do you think about using both Consul and Istio? So Consul to provide the service registry and discovery, and Istio for the L7 features.
I'm just trying to think whether it would actually work. The problem is that when for our service discovery, what we're doing is we're using our service catalog. And the service catalog in terms of the mesh, because of the service identity, is also tightly integrated as well. Istio uses etcd and core DNS and the sort of the service catalogs inside of Kubernetes. So I think you might struggle to get that to work. The one thing I would say though is that we both use Envoy under the hood. So both Consul and Istio are ultimately configuring Envoy as a data plane. So with the 1.6 release, and I must admit we're playing catch up in some ways, but with the 1.6 release, which is coming out very, very soon, you're going to be able to configure all of those L7 capabilities as you can with Istio. So I don't think, to kind of recap, I'm not sure you'd be able to get it to work, but I genuinely think that with the 1.6 release, which is coming out soon, Consul is going to offer many of the capabilities anyway, so you potentially could just check it out as a first-class citizen. And plus, you're going to be able to get that capability of all of those layer 7 and service mesh across between Kubernetes and virtual machines with very, very little effort.
Thank you, Nick. And I want to thank everybody for their questions today. First and foremost, let me thank Nick and Eugene for their time today. And if we didn't get to any of your questions, feel free to reach out to us, as Nick mentioned. I do hope that everybody found this presentation valuable today. And again, the session has been recorded and it is going to be posted on our website, usually within 1 to 2 days of post-processing. I want to thank you all for attending today's webinar and have a great day.